So my name is Mihaela Ștefan. I am a professional services engineer at Infinet Wireless. Thank you very much for taking the time to join our webinar. Today we are going to discuss about the Infinet Wireless solutions for mobile objects. You will learn the basic connectivity scenario for mobile objects and what are the useful Infinet features in order to ensure a proper communication. In the end, we will check some specific applications and what are their particular demands. Let's first review the basic mobility scenario. We are given a predefined path between points A and B inside the enterprise's area of interest. One or more mobile objects are supposed to be moving along this path. The network control center is located at a certain distance from the moving objects, and a real-time connection between the two endpoints must be available. The goal of the project is to provide reliable wireless connectivity between the control center and the mobile objects in order to sustain various services like telemetry data, video surveillance, internet, and so on. Let's see how we can organize the actual connection. First, we need to install several overlapping base station sectors, like you can see in the picture, so that wireless coverage is available at any location. Wired links can be used to collect the data into an aggregation node where the Infimax device is installed. Next, a backbone wireless connection is used to transport the data directly to the network control center for processing. The choice of the equipment for the backbone link is mainly related to the capacity demands, and Infinet offers a vast range of available options. This sums up the basic mobility scenario that I wanted to present. We will now briefly review some of the solutions offered by Infinet Wireless for mobility projects. Let's begin with frequency roaming, which refers to changing the operational frequency of the radio link. Similarly to instant DFS, when channels with a lower interference level are detected, the current frequency must be switched to the new one. In order to participate into the roaming process, the units must have the roaming parameter value set to either leader or to enable. The leader will decide when to change the frequency, and it will inform the remote unit to change it as well. Next, we will talk about the radio profiles. In order to be able to connect to several base stations along the path, the CPE that is attached to the mobile object must include a radio profile for each base station. The radio profiles mainly contain the specific radio configuration settings of each base station. Another key feature is multi-base station. The disadvantage of classical roaming is that after breaking the connection with the current base station, the CPE tries to restore this connection, and only after several unsuccessful attempts it searches for a new base station. When enabling the multi-base station feature, if the CPE notices a negative trend in the signal quality, it preventively breaks the connection and immediately searches for a new device to connect to. So this shortens the disconnection time. Next, we'll review the benefits of the Infimax device. The main advantage when using an Infimax is that you can join all the devices into a single Mint area, resulting in an easy switch group configuration and a unitary QoS policy implemented only on the Infimax device. Additionally, our devices perform continuous link quality monitoring. This is very important because the devices will adapt quickly in real time to any possible change in functional parameters in order to provide the best transmission quality at any moment. This task is of course performed by Mint, and we can see in the picture a network comprised of several Mint nodes. Let's assume that the mobile object is connected to node J and it needs to communicate with the monitoring center that is located behind node F. We will next understand how Mint selects the best path in real time in order to transmit data between node J and node F. First, you should know that Mint performs hop-by-hop routing and maintains a routing table, like you can see. This routing table contains information about the alternative path to reach each destination in the Mint network and specifies the cost for each path. The lower the cost, the better the quality of the transmission, so the path having the lowest cost will be chosen to route the frames. Let's now check the routing table of node J and see what routes it learned in order to reach node F. The first path is through nodes H and G, having a Mint cost of 35, as you can see in the picture. The second path is through nodes C, B, and D, and it has a higher Mint cost of 47. The last path is through nodes I, D, E, G, and it has the highest Mint cost of 51. Since the first path through nodes I and E has the lowest cost, it will be selected to send the frames from J to F, as you can see in the picture. However, the quality of the radio link might deteriorate due to congestion, interference, or meteorological conditions, for example. In this case, Mint will recalculate the costs for each path in order to adapt to changes in real time. We can see that the cost for path 1 has changed from 35 to 50, and it is no longer the lowest cost. Therefore, Mint will decide to switch the transmission of the frames through path 2, which now has the lowest cost. Each decision to change the active traffic path can take place between 1 and 3 seconds, depending on the Mint protocol settings of the unit. I also want to emphasize that Mint is specifically designed for routing frames in wireless networks, where the radio conditions fluctuate, so a quick adjustment of the cost is mandatory. Moving forward, our units provide radio link connection management. The decision about switching the connection from one base station to another can be taken by assessing the SNR threshold values. Two thresholds are used to control the radio link connectivity. High amp is the minimum SNR value required to establish the radio link between the devices, and it is set to 2 dB in our example. Low amp is the minimum SNR value at which the radio link is broken because of signal level degradation, and it is set to 0 dB in our example. We can see in the picture two mobile objects, each having a CPE installed on top. Since the SNR value is above both thresholds, the radio links with the base stations are both established. However, when the signal level at CPE1 degrades and becomes -3, as you can see in the picture, the radio link with CPE1 is disabled since the SNR is below the low amp threshold. Let's now check the influence of the high amp parameter. If a value above 2 dB is registered at CPE1, the link will be re-established. We can see that now the SNR is 4 dB, so the radio link with the base station is re-established. I hope that the significance of the high amp and low amp parameters is now clear for everybody, so let's move forward. We'll delve into the details of the global function, which is very useful for the mobility scenarios. The main idea is that a device that has the global function enabled will only establish connectivity with devices that are detected as having the global function enabled as well. Let's suppose that the cabled connection between base station 2 and the Infimax is damaged. We will see what happens when the global function is not enabled. The CPU on the moving vehicle will first establish a connection with base station 1 as it is in its coverage area. As it moves along the trajectory from A to B, the vehicle enters the coverage area of base station 2 and it establishes a radio link with it, not knowing that the link between the Infimax and the base station is broken. Next, it enters the coverage area of base station 3 and establishes the radio link with it. We can see that even if no data is transferred to the control center between base station 2 and the Infimax, a radio link is still established with base station 2 and data gets lost. Let's now consider the scenario when the global function is enabled on the CPE and on the Infimax device. All the base stations will inform the CPE that they have a connection with the Infimax, which has the global function enabled. They act as proxies. First, the CPE will establish a radio link with base station 1. Next, even if the vehicle enters the coverage area of base station 2, it will not establish a link with it because it does not report any connectivity with a device having the global function enabled. So it remains connected to base station 1. Further, as it enters the coverage area of base station 3, it receives information about the Infimax device, so it establishes a radio link with base station 3. As you can see, no time or data are lost by establishing or using the connection with base station 2. So we conclude that the global function is very useful in such situations. I just want to add one more thing, that a proper frequency planning should be used for the base station sectors, as you need to overlap the coverage of the sectors in order to provide seamless connectivity. Another important feature is that you can arrange for a seamless roaming scenario where no interruption whatsoever takes place during the data transfer. And even if the time to re-establish the link might not be noticeable to the end user, it still exists during the data transfer when only one CPE is installed on the moving vehicle. In our new scenario, we have two CPEs installed on the moving vehicle, one at each end of the vehicle. As you can see, initially both CPEs have radio links with base station 1. As the vehicle moves along the trajectory, CPE 1 is still connected to base station 1, but the SNR at CPE 2 goes below the low amp threshold, and the link with base station 1 is interrupted since CPE 2 is also farther away from it. Next, CPE 2 tries to connect to base station 2 since it enters its coverage area. In the meantime, data is still being transferred through CPE 1 towards base station 1, so no interruption is noticed. In the end, CPE 1 loses also connectivity with base station 1 as it goes farther away, but the link between CPE 2 and base station 2 is already established. You can see that each CPE independently establishes radio links with the base stations, and the data transfer is continuous with no interruption. It is important to add here that the Infimax is responsible for choosing the route with the lowest cost for transmitting the data when both CPEs have their radio links active. Let's now briefly review the Mint modes. The Infilink 2x2 and Infiman 2x2 family devices allow you to configure the following Mint modes. Fixed, where the radio parameters are evaluated every 3 seconds. This is suitable for fixed radio links involving no mobile objects. Nomadic, where the radio link parameters are evaluated every 1.5 seconds. This mode is suitable for slowly moving vehicles. Mobile, where the radio link parameters are evaluated every 1 second. And this mode is suitable for fast-moving vehicles. The mode selection affects the analysis of the radio parameters when the multi-base station function is enabled, and the device in a fixed mode evaluates the radio parameters every 3 seconds, so it is more resistant to link interruption under short-term interference compared to a mobile device where the analysis is performed more frequently. In the last section of the webinar, we will review some of the practical applications related to mobility projects and what are their particular challenges. Let's begin with the mining industry. The main setup includes base stations installed along the quarry perimeter in order to provide the coverage of the whole mining area. The mobile objects have one or more CPEs installed on top, featuring either omnidirectional antennas or directional ones, depending on the project specifics. At the aggregation node, an Infimax is installed, as we discussed so far, and further, the data is transmitted through the backbone point-to-point link towards the control center, as you can see in the left side of the picture. The specific of this project is the operation in harsh environment conditions. The Infinet outdoor units respond to this demand by providing a reliable communication in a wide temperature range and by being resistant to temperature extremes, wind load, dust, and water. Regarding the settings, we recommend the following. Join all the base stations sectors into a single mint area using the Infimax. Use the nomadic mode and enable the global function. Next, let's check the railway transport system. Here, the base stations are installed along the railway and 2 CPEs are set up on the train, more specifically one at each end of the train, as you can see in the picture. The aggregation and backbone design are similar to the scenario we already discussed. The specific of this scenario is the high maximum speed of the train, which requires a careful planning of the base station's locations and specific device configuration. The following settings are recommended. Join all the base station sectors into a single mint area using the Infimax. Use the mobile mode in this case, as we have increased speeds. Enable the multi-base station and the global features. This sums up the details for the railway transport. Let's now review the transport over the water. Here, the base stations are installed usually in the seaport area along the coastline, as you can see in the picture. The network connectivity with the control center follows the basic scenario that we have presented so far. What is special in this case is that the communication takes place mainly over the water surface, which induces many reflections that cause inter-symbol interferences at the receiver. To reduce the effects of the inter-symbol interferences, a guard interval is used between the transmitted symbols, and its value can be increased from the configuration. Rolling should also be considered in order to maintain the position of the CPE relative to the base station. A roll compensation device with a gyroscopic function can be used. For the recommended settings, you first need to join again the base station sectors. The nomadic mode should be used, and both the multi-base station and global functions should be enabled. Last, we have the smart city projects that also involve moving vehicles with different purposes. In a smart city, you will find base stations installed at street level on pylons, traffic lights, or buildings, and several vehicles with CPEs on top. In case of traffic control systems, it is important to provide reliable real-time communication using a high-quality connection with low jitter and delay values. CCTV systems are also very often present in a smart city and require an increased throughput in the uplink, along with advanced multicast traffic handling mechanisms like IGMP snooping. Also, providing triple play services for the passengers in public transportation systems is an important aspect, our units can successfully meet all the demands that we reviewed by ensuring superior data transmission quality, a rich networking feature set, and a vast range of available capacities in order to meet any specific demands. In the end, I want to share with you some new information. We have published in the Infinet Wireless Academy the white paper called The Connectivity with Mobile Objects that includes all the details we have discussed during this webinar. I advise you to read it in order to strengthen your knowledge regarding this subject, which is a bit complicated. The other news is that Infinet Wireless Academy has now a channel at Telegram. You can join this channel in order to receive various notifications about technical user manuals, white papers, new online courses, events like webinars or trainings. This brings us to the end of today's presentation. Now, if you have any questions, please feel free to write them down in the chat section, and I will answer them one by one. In the meantime, we will just have a short break. Thank you. We are back for the questions sections. You asked about the presentation. I have uploaded the presentation so you can download it. There you have the link with the white paper about the mobility projects, and you can find all the details in this document. Next, we are asked if the Infimax is a hardware. Yes, the Infimax is a switch running Mint, so you can configure switch groups, QoS policies, and it helps you to ease the configuration of the overall devices in the network. Basically, if you install Infimax, you can join the devices in a single Mint area and apply switch group configuration and QoS policies only on the Infimax device, with no additional configuration on the other wireless units. So the Infimax is not a wireless unit, it's just a switch. About the diagram, you saw, if you will review our presentation, you will see that in the first two slides with the basic scenario, you have the Infimax present in the scheme. It is the connection point between the backhauling section with the base station sectors and the backbone link towards the control center. I see that someone is implementing in Senegal some fast train solutions. Yes, I think this webinar and the features that we reviewed should be very useful. You need to enable multi-base station, global function, and consider all the advices that we presented, and the solution should work fine at any speed. Our colleague Olga also sent you in the chat the link for the Telegram channel, where you can find all the updates about the documentation and our events like webinars and the trainings. Okay, I see there are no more questions. Thank you once again for your time, and I hope to see you again during our next webinar. Have a nice day.